Okay, today we're going to talk about polynomial inequalities. Okay, now in Algebra 2 you learned about linear inequalities that look like this, where y was less than or equal to 2x minus 2. And basically, for linear inequalities, you graph the line either as a dotted or solid line based on the inequality symbol. So if this was not equal to, it would be a dotted line. If it was equal to, it would be a solid line. Then you'd plug in a point and to see which side was your solutions of that line, and then you'd shade the correct side of that graph. So basically, you'd graph your line. So there's my -2, I have a slope of 2, so rise 2, 2 over 1, 2 over 1. So the line would look like this. And of course, since I have a equal sign, it's a solid line. So I'd get this. This is the line. Okay? And then I'd figure out, okay, well, if I pick an x, say I pick x is 2, right? So here, x is 2, y is 0, right? So you plug in 2. 2 times 2 is 4. 4 minus 2 is 2. Is that greater than or less than? And that'll tell you your solutions. And then you shade whichever side it is. Okay? So that was basically in Algebra 2. So the y's were the ones less than. So it's going to be this side here. Okay? All right. Now, we're moving to pre-calculus concept. Okay? And our pre-calculus concept, instead of linear inequalities, we're talking about polynomial inequalities. And our polynomial inequalities look very similar, except that we don't have it equal to y. We usually have it equal to a number or to a value. And basically, we're saying find the solutions to this where this function is greater than 0. Okay? So basically, you need to find out where your function is first 0. So find the zeros of your function. Well, my zeros of my function are x equals 0 and x equals 5. Okay? So I'm going to, on a line chart, we're going back to middle school, I'm going to create my line chart. So here's x equals 0, and I'm going to put a little 0 there because that's telling me that's a 0. And this is where x is equal to 5, and that's also a little 0. Okay? Now, that means that on these two sides, or in between these, is where our possible solutions are, because this is where my function is 0. Okay? So now that I know where it is 0, I need to find out where it's greater than 0 and where that's less than 0. So to do that, we actually will pick a number. You can pick any number you want that is smaller than 0. I'm going to keep it simple, and I'm just going to pick 1. Okay? Negative 1. Is negative 1 smaller than 0? Absolutely. So then I'm going to plug negative 1 into my factors. Okay? Now, when I plug negative 1 into this factor, I'm going to get negative 2. Okay? Because 2 times negative 1 is negative 2. When I plug negative 1 into this factor right here, I'm going to get negative 6. But then negative 6 squared is going to be a positive number. Okay? So now notice I didn't put the values because I'm not worried about the values. I'm worried about whether that number is positive or negative. Okay? Because really I'm trying to find out things that are greater than 0, that's just positive numbers, versus things that are less than 0, which are negative numbers. So when I take a negative times a positive, this is going to be negative. So let's pick a number here in between 0 and 5. Again, keep it simple. I'm going to pick 1. When I plug 1 in for x in this factor, I'm going to get a positive number. 2 times 1 is positive. And then when I plug 1 in here, again, 1 minus 5 is negative 4, but then when it's squared, it's going to become positive. So a positive times a positive means this net's positive. Okay? And again, I'm going to do the same thing over here. I'm going to pick a number bigger than 5. I'm going to keep it simple, 6. And again, I'm going to plug 6 into each one of my factors. 6 times 2 is 12. That's a positive number. 6 minus 5 is 1 squared. That's a positive number. And then positive times a positive will be positive. Okay? Now, since I'm looking where the numbers are positive, I'm going to use these to tell me where my solutions are for this. So I'm looking for when this is greater than 0, which are positive numbers. Okay? Numbers less than 0 are negative, greater than 0 positive. So this is my shortcut. Okay? So now that I have this graph, this number line set up, wherever I find my solutions, so anywhere I came out with these big positives, those are where my solutions are. That's where I'm going to put my x's. Okay, so under these big positive signs, I'm going to put my x. Okay, then these zeros, the reason I put them there is so that when I get to this point, I can put my zeros down here. Okay, so I'm going to bring my zeros down. So the x represent where my solutions are. These are my zeros. Now, because I don't want to know where it's equal to 0, only where it's greater than 0, I'm going to put in a less than symbol there, a less than symbol there, and a less than symbol there. So anywhere I had between an x and a number, I put a less than symbol. Okay? If this were equal to, then I would have put an equal to there. And we're always going to use a less than symbol when we're doing this way. Okay? It doesn't make sense to do it the other way, to do greater than symbols. So basically, what I've done is I've created my solutions because this solution set, this is positive between 0 and 5. So my solution is from 0 less than x less than 5 in union with when x is greater than 5. So these are my solutions, between 0 and 5 or when x is greater than 5. If you like, you could write it as a brackets and all that. If you wanted to do it that way, then you could write it like this: from 0 to 5, union 5 to infinity. And that's basically the same thing as that. Okay? Now, that solution set should look sort of familiar. Okay? That equation came from one of our other notes that we were doing when we did this graph. These solutions represent this graph. And look, if you look at where this is negative, it's negative here. Positive between 0 and 5, my y values here are positive, and positive afterwards. They're all positive here. This equation matches the equation for this graph that we did. And this chart should match the graph as well. These are where the y values are greater than 0, where the positives are, and where it's less than 0, where the negatives are. So it all relates basically back to what we've been doing with graphing. Okay? So we'll do another one so you can kind of see what we have going on here. Again, so I have this equation here. Start with my zeros. Okay, I want to know where this is less than or equal to 0. So I'm looking for where this is negative. Okay, but I got to figure out where it's 0 first. So that's x equals 0, x equals positive 4, and x equals negative 6. Okay, put those on my number line. Negative 6, 0, and 4. Those are my zeros. And again, all I'm going to do is I'm going to test numbers. I'm just going to pick numbers. I'm going to pick a number smaller than negative 6. You know what I'm going to pick? I'm going to pick negative 10. Does it matter? No, as long as it's smaller than negative 6. When I plug negative 10 in here, negative 10 squared, positive, but that's going to make it negative again. So my first one's negative. When I plug negative 10 in here, I get a negative. When I plug negative 10 in here, I'm going to get negative. And a negative times a negative times a negative is negative. So it's negative there. Okay, so here I'm going to pick negative 1. When I plug negative 1 in there, I get, well, it squares it, becomes positive, but that makes it negative. So the first one's negative. Second one, negative, but this one becomes positive because negative 1 plus 6 is positive. So negative times negative is positive times a positive. That one's positive there. Pick 1. Again, plug 1 in, square it 1. That makes it negative. This is going to be negative and positive. So this nets positive. And then I'm going to pick any number bigger than 4. Like again, I can pick 10. Negative 10 minus 4 is positive, so this is positive number cubed, is still positive, and this becomes positive, which means a positive times a negative is negative. So here we go, where we're going to write the solutions. Okay, so again, I'm looking for where this is less than 0. Less than 0 numbers are negatives, so I need my negatives here and here. Okay? Then I drop down my zeros, negative 6, 0, and 4. Again, anywhere I see an x and a number in between there, I'm going to put a less than sign. And since this is equal to 0 as well, I'm going to have to put an equal sign adding to it. Now I have this 0 right here all by itself, which means I also have to say, okay, I need that one as well. So my solutions are when x is less than or equal to negative 6, union with x equals 0, union with x is greater than or equal to 4. And again, if you wanted to write this in its with brackets and parentheses and instead of inequality, this would be from negative infinity to negative 6 with a bracket because it's equal to. This one would still be x equals 0 union, and then this one would be from 4 with bracket to infinity. And that's polynomial inequalities.